Hello, good morning everyone. Today, inshallah, we will continue with our lecture. This is our third lecture for this semester. I'm with you today, I'm Dr. Omar, and we will continue topology in RN as you will see. As I usually say at the beginning of each lecture, all of our coursework and everything, you will find them on Moodle. Also, the previous exams and everything, you will find them there. And I encourage you just to go through the previous exams and to try to solve as much as possible. Also, the recorded sessions, you will find them all on YouTube, starting from the beginning of this course and inshallah till the end of this course. As I told you, we are in the set of Rn, and there is some topological notations in Rn that we will need down the road, so it will be introduced today. One of the important things to start this part with and to keep in mind is simply the distance between 2 points. It's the entrance of our lecture today. You're already familiar with it as the distance. It is already the norm between two, the norm of a vector, or the distance between 2 points, and you will see, and it will play a very important role. So once more, the Euclidean distance between vectors x and y, it's going to be the square root of the difference between the coordinates of both points. It's exactly like the norm, and you can write it d and x over y, or the norm of x minus y, or simply this is the equation that we will use. Almost the same as normalized triangular inequality. Okay, it's exactly the same. It's the same for the normalization. That's the distance of xy is greater than or equal to 0 for every xy belongs to Rn, and the distance will equal to 0 just only when x is equal to y. D of x or y, it's exactly like d of y or x, as long as you are taking the same pattern for the difference between the coordinates. So if I'm considering in R3, for example, so x stands for the first point, which is x1, x2, x3, y for the second point, y1, y2, y3. It will make no difference, there will be no difference if you take the distance from x to y or from y to x. The result will be the same. Also, the triangular inequality, d from x to z, it's less than or equal d from x to y, then from y to z, as you can see, for every x, y, and z belongs to Rn. Also, as we introduced in the normal or in the norms in the previous lecture, it's exactly like there's different types of distances. So I can have distances, distance of a sum, which is really very close to the norm of a sum, or the general equation of a norm of a sum. Also, there is distances that do not arise from norms, like the distance can be defined as any map from Rn to Rn and from 0 up to infinity, as we will see down the road. So now I will start with a bunch of definitions, and that's mainly the main reason of today's lecture. We will start with a very important definition with the open ball in Rn. What's an open ball in Rn? It's really very important concept. It will play an important role in finding the limits, in finding the neighborhood of a certain point. So it's really very important. So it is defined like this. Given a vector A belongs to Rn and a real number R greater than 0, in most cases we use also epsilon greater than 0, we define the open ball of a center A and radius R at the set. It is said like this: the open ball at A with radius R is equal to all the numbers or all the points belongs to Rn such that the distance from x to a is less than r. Also, the distance between x and a, as we saw in the previous slide, it's the distance between x minus a, or the norm of x minus a. So, number one in R, if I'm talking about the real set, just only the real set, simply the definition of an open ball of R, so if I wrote B at A with radius R, it means if this is R, just only R, one dimension, and this is point A, so I will have R or theta, so it will hit here at A plus R, and it's an open point because it's an open ball, and also the radius will go to the other side and the hit at A minus R. So we mean the set which contains all the numbers in the neighborhood of A, or the open ball represent the elements that belongs to from A minus R up to A plus R, as you can see. If I'm talking about a two-dim, if I'm in the two dimension, the open ball in this case, if I wrote B of A with radius epsilon or something, that means this is the x-axis and that's the y-axis. So, I'm sorry, this is the x-axis and that's the y-axis. This is point A and here is epsilon, and in this case it's gonna be a circle around the A without the boundary. This is why it's called an open ball in two-dim, as you will see. So once more, if I'm talking in R, just only in R, the open ball will be simply the interval, as you can see, from A with radius R, that will give you the boundaries of your interval. If I'm talking about, that's an open ball in interval centered in A. If I'm talking about an open ball in R2, considering the points as A and B, it's very simple, and it also will represent, or will be said, the open ball at A with radius R, where XY, because I'm in R2, that belongs to R2, such that the distance from enormous point X and Y to A and B is less than R, which means it is the difference between X minus A to the power of 2 plus Y minus B to the power of 2 under the square root, exactly right, which is less than the radius of your circle. And in this case, this is the shape of your ball. This is point A, that's radius R, and that's the open ball. As I told you, the points in the neighborhood of A without the boundary of A. If we move to R3, so once more in R2, considering the Euclidean norm, or an open ball at A with radius R is an open circle centered in A with radius R, but without the boundary. In R3, it will be considering the Euclidean norm as an open ball, so it's a sphere with radius at A, in this case, without the surface centered in A. Once more, I've tried to reform all of what I said in the previous slide, in this slide, but with also another definition, another shape of your equations that you will be familiar with in other books or textbooks. So, once more, B at A, it's an open ball, the symbol of an open ball, at A with radius R, which represent all the points within Rn, such that X minus A less than R, where R is greater than 0. Okay, here is the set, here is it's written, how it is called an open ball, it's written. Those are three cases beside each other. That's if you are in R, that's if you are in R2, and that's if you are in R3. In R, it will be the interval between, or the open interval between A minus R to A plus R. In R2, it will be a circle without the boundary. In R3, it will be a sphere without the boundary. By the idea, a definition of a closed ball, the symbolization is B, but it has a dash on it. So B dash around the use radius R, it's exactly like X belongs to R, and such that the distance is less than or equal to R. In this case, in the first inequality, we didn't have an equality sign. So the boundary is not involved with us in the definition of the open ball. But here we have less than or equal, which is the definition of a closed ball. So this interval will be exactly the same, but with a closed endpoints for your interval. And if I'm in R2, it will be a circle including the boundary of the circle. If I'm in R3, it will be a sphere including the surface of your sphere, as you can see from this slide, which represent the definition of an open ball. And once more, BR at A or BA with radius R in the set of all points in Rn. Look to the meaning. It is all the set of the points in the neighborhood of point A, if this is point A from the left or the right, or to point A around it, or in the middle of this sphere, point A, or the neighbors in the points in the neighborhood whose distance from A is less than R. It's called the open ball, was centered at A and radius R. The closed ball is exactly the same, but it includes the interval, the end points, or the surface, or the outer circumference in the case of a circle, as you can see. The definition is very, very important. As you will see, it is the keystone for what's coming after that. I want to also define now some definitions, and we will extract them or look to them in a deeper point of view in the next couple of slides, just to make those definitions completely set in your mind. So now let A belongs to Rn. So A is a point, belongs to the set of Rn, and the A is a set, belongs to Rn. So now I'm defining two things. I'm defining a point and a set. A point and a set. Okay. The point and the set are both in Rn. So it could be in R or in R2 or in R3, as we saw in the previous lecture. If A is an interior point of A, so if A small, which is a point, is an interior with respect to the set of A, then it will satisfy this condition. So there exists a radius, okay, greater than 0, such that the open ball in A is completely contained in A capital. Because of Mr. Adham just arrived, I want to repeat this definition once more. We already defined what's an open ball, but quickly, an open ball, it represents a neighborhood of a certain point. So if I say in one dimension, the symbol B at A with R, it's the open ball with center A, okay, and with radius R. And it will represent, this definition, represent the set of points around the point A. This is point A in the middle. So it is the set of points around point A without the endpoints of at R. So if I'm talking two dimension, the neighborhood of point A, it will be the circle, the points of the circle, all around the points of the circle, without the outer the perimeter of the circle. If I'm talking in 3D, it's gonna be a sphere with A in the middle, and the R is greater than 0, and it is around it. Okay, so once more, if I want to define the case of a point with respect to a set, so now I'm moving. Now I've understood what's a point. It's the corner, it's the center. And around it, there is a neighborhood. This point, with the rounding, that's surrounding of this point, which is the open ball, I want to see if it belongs to a set, or it is not, it doesn't belong to a set or to a boundary and something like this. This is why we are going to this definition. So once more, A is a point, belongs to Rn, where A capital is a set of points, belongs to Rn. So A is an interior point of A capital. So this guy will be an interior, one of the points of AF. there exists r greater than 0, so there is exist an open ball such that the open ball at A with radius r is completely contained in A. That means an interior point. With the same definition, we will show more clarification for this. The exterior point, with the same definition, it's for A. If there exists r greater than 0, such that BRA, or the open ball at A, centered at A with radius r, belongs to Rn except A. What's the difference between this guy and that set? Between this set and that set? The first set represents A. The second set represents the universe without A. Or A complementary. Or everything else but with no A. So, if it says exterior point, so it doesn't belong to A. It will belong to the whole universe, but without A. Okay, what's a boundary point? The boundary point A, it's called a boundary point of the set AF. For every R greater than 0, خلي بالك, the open ball centered at A with radius R intersection, the set of A, doesn't equal to phi. What's the meaning of doesn't equal to phi? It means it intersects partially, okay, with the set. Also, and also intersect the outer. So it's an internal and external point at the same time. To make your life easier, okay, to make it easier, let's look to this case. If I have, that's a set of A. So if I consider this is the set of A capital, that's the set of A. We will call A small an interior if it is in here, A, with radius R, and that's the open ball. So all A and its neighborhood, it's a part of A. And it will be if A is here, so with a radius of R, and that's A, so A and its neighborhood, it belongs to R and except A. So, or A, it will be completely contained in A complementary. All elements without A. But in this case, I have A small is completely contained in A. Then, what if A is a boundary point? In this case, the circle around A, if you get the intersection between it and the main set, it's not going to be phi. And if you get the intersection between this open ball and the external of A, it's not going to be an empty set, because also it will intersect it in this part. In this case, it's going to be a boundary. That's the main definitions of an interior, exterior, and the boundary point. So is an exterior point of A, if and only F, is an interior point of Rn except A. Which means, if it is external point of A, it's an interior point to A complementary, or to the whole universe without A. Okay, the interior of A can be symbolized by int A capital, which means this point belongs to this set, or it's completely in this set. In the set of interior points, exterior of A, it's going to be symbolized by ext of A, which means that belongs to the outer of set A. If it is on the boundary, we can symbolize it by BD equal to A, or BD of A. By the idea, the boundary points sometimes called the frontier, sometimes called the frontier of A. Okay, so it's boundary and frontier. Once more, for any A belongs to Rn, those are some of the remarks that can come to you as multiple choice or to justify or something like this. So, an interior point intersection the boundary, it's phi. Any point belongs to the interior, okay, it's not going to be a boundary point. because the intersection between them is phi. The interior of A intersection the exterior of A is phi. You are talking about points inside and the points outside, which makes sense. The boundary intersection the exterior is also phi. The points on the exterior boundary, if you try to get this set and you try to get an intersection with the exterior, it's going to be phi. Also remark that if you have the interior points plus the exterior points plus the boundary, in this case you will have the whole universe. If I'm adding the points inside with the boundary and the points outside, you will be dealing with the whole universe as we explained. Also, because I know this part is a little bit confusing, so I've tried hard to give you more slides explaining this issue in order to make it very clear. So, interior of a set, I can write it this way: X is an interior point of S. F, that's a symbol, or that's the shape of an interior point, and it will happen if there exists an epsilon greater than 0, such that the open ball at X with radius epsilon is completely contained in this set. Okay? This is how we can memorize how to read it. Okay? So once more, Judy, I can read this mathematical expression in the following manner. This symbol stands for there exists or there is. So I can say there is, okay, an epsilon greater than 0, such that these 2 points, and the open ball at X with radius epsilon, okay, is completely contained in S. Is fully contained in the set S. So that's the symbolization, that's how it should be read. The set of interior points of S in the interior of S and symbolized by interior of S, and that's also the shape of a point, that's all the points within the interior. Bottom line, I have the set and the interior points are the points, and also you said the neighborhood of these points. What's the meaning of a neighborhood of these points? The points who are closed, very close to this point. So if I'm talking about point A, it's not just only point A. No, it's point A with all the points in the neighborhood around A, which is called an open ball, previously defined in the previous slide. Also, once more, interior point, another definition. Sometimes it's symbolized in this symbol also. This is exactly like this one, Miss Judy. That symbol and that symbol, they are exactly the same. Here I'm stating that the open ball at point X was radius R. Okay? The open ball at point X was radius R. It's contained in A for some R greater than 0. This means you can draw a small bubble around the X that's still entirely within the set of A. Just in case if you forgot it, it's in front of you once more. Okay, exterior of a set, if there exists epsilon greater than 0, so the neighborhood, the point and the neighborhood is completely out of your set. Also with the same definition of the reading, I'll tell you كده Judy, there exists epsilon greater than 0. So I'm talking about the bubble around the point. The bubble is controlled by the epsilon. Epsilon is greater than 0, which means it's slightly greater than 0, okay? So, epsilon, there exists epsilon greater than 0, such that the ball around it with radius epsilon, its intersection S is in this set, in the group of this set. It is equal to phi. That's the meaning of the exterior of a set. If you try to get the intersection you said, it's going to be an empty set. خلي بالك Mr. You said, I'm trying to get the intersection of the neighborhood of this point with this set. لذلك فيها 5. خلي بالك Judy also.
كل حاجة فيها فاي.
اوكي مش كل حاجة فيها 5. لا لأنه البوينت أو الأوبن بول Z اوكي كده intersection S complementary, which means the whole universe without S it's not gonna be phi. Okay, so you have to read it very well. ما فهمتش يعني ايه كل حاجه اسمها فاي، بس ارجو ان انا اكون قدرت اوصلك المعلومه.
قصدي اللي هو فاي سبست من اي ست ولا ده غلط؟
طبعا فاي سبست فروم مجموع فاي.
فالانترسيكشن بتاع اي ست.
بس دي حاجه مالهاش دعوه باللي انا بقوله دلوقتي.
انا فاهمها كده بس.
اوكي بس مالهاش دعوه باللي انا بقوله يعني.
ماشي.
Okay, the set of exterior points of S is the exterior of S. The exterior of S. يعني خلي بالك exterior of S it's an interior of مين؟ تقدر تقول طيب؟
exterior of S.
يبقى interior بتاع مين؟
S dash.
S dash صح. S complementary. روعة. طبعا هنا مديلك الشيب دي إذا كانت دي ال A ودي point X which is an interior point with respect to A. بس ده الشكل بتاع الاكستيريور بوينتس او ده اللي ستاند فور الاكستيريور بوينتس اللي هي الشيدد اريا. طبعا definition exterior of a set برضه تاني once more ان الاكسترنال اوف A هو الانتيريور اوف A complementary او for the whole universe except at A. طيب what are the points at the boundary? Points at the boundary are those points as you can see where the intersection of the open ball at Y with S is not phi, and the intersection with Y with the whole universe except A or with this complementary also is not equal to phi as you can see from the definition, or Y is a boundary point of S if for every epsilon greater than 0 the open ball of any point around the boundary intersection the complementary of your set is not phi, and at the same time the intersection with S is not phi also. That's the definition of a boundary point. Okay, why is a boundary point? Means its intersection with S is not empty, and intersection with the set complementary is also not also empty, which means it is a boundary set. I wanted to write this for you also. Sometimes the boundary points we call them frontier, and they may be symbolized. You can see this symbols like this one, partial of S, which mean the boundary. Or FR stand for the frontier of S. All of them stand for boundary. The boundary point. يبقى frontier كلهم معناهم boundary. Frontier of S or the partial of S as you can see. يبقى the set boundary points of S and the boundary of S, partial of S or the frontier of S, all of them stand for the boundary. يبقى for the time being I have a classification, Judy, of an interior point, exterior point, and the boundary point, okay, with respect to a set. What's the closure? Sometimes it's called the adherence of a set. The closure or the adherence of a set. Simply, it can be looked at the interior plus the boundary. The interior points plus the boundary points. That's the closure of a set. So let A, contained in Rn, the closure of A denoted by A dash is the set of all points in A together with all of its limit points, also called accumulation points, which means the boundary, both of them. So it's an A union, as I told you, partial of A or frontier of A. يبقى انا لو جبت الانتيريور بلس الباوندري هما الاثنين مع بعض يدوني مين؟
اللي هي لو كلوز فكده كده هي ايه ده؟
يعني including الباوندري.
بالظبط.
اوكي؟ طيب A داش ده المعنى، ده معنى كلمة ده معنى كلمة كلوجر. خلي بالك انه الكلوجر مش البوينتس باي اتسلف، لان هي كل بوينت لها نيبرهود. فهو ممكن اسميه الاطار اللي بيحتوي الست بالباوندري بتاعها، لان البوينتس اللي هتابروتش الباوندري هتبقى داخله معايا في الكلوجر. اوكي؟
بس الكلوجر هو
المينلي انتيريور وباوندري
كلهم على بعض.
الانتيريور والباوندري مع بعض. طبعا هنا once more A bar is equal to X belongs to Rn such that for every R greater than 0 the ball intersection A is not equal to phi. Every point in the closure is either in the set or arbitrarily close to the set. ده المعنى اللي انا بقول لك عليه. ان كل point every point in the closure كل point في الكلوجر يعني interior او على الباوندري صح؟ It is in the set or arbitrarily close to the mean to the set لأنها تعتبر accumulation point للباوندري. The closure includes the boundary of the set. It is the smallest closed set containing A. يبقى لو انا حولت، لو دي الست بتاعت A هتبقى الكلوجر هو ال smallest set that I can form around A and contain the A كلها على بعضها. That's all definitions of a closure. اهو زي ما انت شايف ده ال A ده الباوندري وده ال A داش هو لامم ال A بالنيبرهود بتاعها as you can see. So it is the interior plus union the frontier of or C union frontier of C as you can see. Open and closed sets. C is said to be open if C equal to the interior. C is called the closed point if C equal to the closure as you can see from this slide. Also definition A of the closure, once more A in the set of A dash which is A plus the boundary. Let A belongs to Rn, so A is an open set, it means F is the interior of A, then closure, our closed set. Remarks, an interior plus BD, boundary, it's going to be the closure. A is closed if and only if a boundary of A is contained in the set, in the main set. And all of these I've tried to collect as much as possible from the statements that you may face in your exams or in textbook or in free reading in order to see them all and what they stand for in this couple of slides. طبعا A is a limit point of A if and only if there exists a sequence of A and of elements of A distinct from A such that the limit of this sequence is going to equal to A, which means the points in the neighborhood of A, the points that will approach the point A small. Are you with me? This is the limitation. Also, I have a definition for an isolated point. What's the isolated point? The isolated point, it's the point. Once you get that intersection between it and your set, it's gonna equal to exactly this point. So the intersection will involve this point only. Or the intersection will be fine. That means isolated point. So it is the point without its neighborhood, yeah, Mr. Yusef. ماشي? So once more, as I told you, A is a closure point, F for every epsilon greater than 0. The open ball at A with epsilon, intersection S doesn't equal to 5. A is an isolated point, F. If I try to get an epsilon, and I'm trying to get the intersection between the open ball and your set, and the only intersection is just only A. So, sometimes the points by itself is an isolated, like if you have a sequence of numbers. If I have a sequence 2, 4, 6, 8, 10, and so on, that's a sequence of numbers. So, but these points belongs, we can call them a set of numbers, okay, or a set of an arrangement. But they are a set of isolated points. لأن 2 just only 2, not the neighborhood of 2. So it's just only 2, it's not an interval. 2.01 doesn't belong to your set, and so on. Okay, that's called the isolated point. So the isolated point is a special closure point. Okay, for another, we can define it this way. So the isolated point is a special closure point that we can find an epsilon such that the intersection with the main set is only A. So the intersection will result just only this point. Open and closed sets and compact sets. The three definitions are really very important. For an open set, I'm talking about the open set, the closed set, the compact set. So I'm not talking about a classification of a point. If it is interior point, exterior point, or a closure point, or a boundary point. I'm moving to another thing. I'm talking now with the definition of a set. Okay, so we say that S, the set S, is an open set if it coincides with its interior, without the boundary. So I can say S equal interior of S, which means open interval or an open disk or a sphere without a surface, if you remember within the beginning of the slides. In the case of a closed set, it coincides with its closure, which means the interval and the boundary. Okay, معايا أدهم? Okay, that's the case of a closed. A set is said to be compact if both closed and bounded. So the set should be closed and bounded. Do you know what's the meaning of boundedness?
Boundedness.
The boundedness means that your set is between two numbers, even if these two numbers are within your set or without your set. يعني are within your set or without your set. يعني if for example I can say that
يعني مفيش infinite.
بص مفيش infinity. يعني اقدر اقول x belongs to the open set C and D. In this case it is bounded. It's bounded by C and D. And also I can say that x belongs to closed C and D. It's also bounded. You understand what I'm saying? But this set is an open set. That set is a closed set. Are you with me? So actually that's a compact set. فاهمني؟ معايا يا شباب؟ But if the set x belongs to from negative infinity up to D, in this case, okay, it is not a bounded set. It's not bounded from blue, or it's not bounded from above, or it's not bounded from both sides. If it runs from negative infinity up to positive infinity. In this case, this set's not bounded. Okay, Shabab? Okay, really very good. Also, here you have the isolated the A is an isolated point condition, and if A is a limit point, look to the definition of a limit point. For every r greater than 0, there is an open ball centered at A with radius r. Intersection A without A doesn't equal to phi. So, which means, back Mr. Hussein, sometimes the numbers are not involved in your set, but the neighborhood of your point belongs to the set. Like if I told you the set of rational numbers belongs to the interval from 0 to 4. Tell you once more. The set of rational